things first, we are going to brief about the automotive industry and why the electromagnetic compatibility matters to it, or in short we will call it EMC. From an EMC perspective, the evolution of drive system into today's cars proves to pure as a challenge. Well, this is mainly because future drive concepts for automotives are built to revolve around higher efficiency, meaning to say that today's cars use way more advanced technologies than before. And when you're having newer technologies, there's gonna be a bunch of issues you're going to have to consider. For example, the electromagnetic interference. Now, the new components, which is the electric drive system, consists of a high voltage power source, a frequency converter, an electric motor, and high power cables. Now, why is EMC important to the automotive industry? Well, this is because these components and assemblies that contain many more active electronic components than in the past may emit radio frequency noise or be exposed to external sources of energy, therefore resulting in unanticipated changes in system operation. Moving on is our target market. So for automotive, there are two sources of electromagnetic interference. One is on-board and one is off-board. So off-board vehicle sources are basically sources that come from outside the vehicle that provides an electromagnetic interference. For example, a lamppost, a traffic light, or a power tower. Now, we choose to focus on the onboard vehicle sources, meaning to say that the electromagnetic interference comes from within the vehicle itself. Now, the common equipment inside an automotive will produce a high radio frequency levels, and each of the components act as a path for electromagnetic emissions. Now, some of the components that provide high radio frequency levels are power converters, electric motor, and traction batteries.
Hi guys, so my name is Sai and I am the one who in charge to tell you guys of problems and also solutions in EMC case studies. So first thing first, I would like to tell you guys we will be discuss about two parts in EMC's case study, which are the emissions and also the immunity. So we will divide these two parts in problems and also solutions. So what is emissions? Emission is like when the microprocessor clock harmonic was on two-way radio frequency. It is rendering the radio communication impossible. So it makes the radio communication impossible because of the two-way radio frequency. This is in emissions. So next we move to immunity. What is immunity? Immunity is one of the automotive characterization of susceptibility, and I am sure you guys must know what is susceptibility, because this is the general statement in EMC's case study. So in immunity, it is like an engine had transmission seemed defective due to the control malfunction, because it was a change from a metal to a non-conductive component package. So it makes the immunity of that particular machine being so high. So I move to the problems. So I'm here to talk about the problems that we have identified in this case studies. There are a few problems in EMC we should consider in automotive industry. I would touch into the emissions issues first. For the problems in emission issues is, first one is high power devices designed for lower power dissipations. Remember, the high power devices designed for the lower dissipation. This is results in operation at an order of magnitude faster than the responses of electromechanical devices. So when the operation at an order of magnitude is faster than responses of electromechanical devices, it causes the emission issues to be radiated and conducted. So this makes the emission issues become bigger and bigger. So next we move into the slew rate of high power devices. Slew rate of high power devices is actually the continuous part of the first one I said just now. So what is the slew rate? Slew rate is the maximum rate at which an amplifier can respond to an abrupt change. So the abrupt change of an input level. So the change of voltage or current or any other electrical quantity per unit of time in the device, that is the slew rate of the devices. But the devices must be the high power devices. So that is the issues. What is the problems in immunity issues? The problem is, the problems that I found out is not that much, so I will just say it now. So the electronics modules that radiate energy may also be efficient, unintentional receivers of energy. Remember, it also may be efficient unintentional receivers of the energy. So therefore, the radio frequency sources may affect the operation of active devices with the following implications. So there are some implications that we should consider in this case, which are control of vehicle functions, entertainment system, and also legislated requirements. So the legislated requirements is like the tire pressure monitoring. So that is the problems in the immunity issues that I found out. Okay, we're done with problems, so we move to the solutions. So okay, I would touch in the solution in the immunity part first, then I will move to the emissions, because we just discussed about the immunity's problem, so it is easier to understand if I touch in immunity first, then we move to emissions. So here are some solutions we will provide according to a research that I found conducted by Nur El Syifa in the internet. I found it. So Nur El Syifa is so credited. I credited this video, the solutions parts from the for Nur El Syifa from Electrical Engineering Department of University of Michigan on Automotive EMC Introduction and Overview. The slides was very good, so I understand very clearly. So the first one, the solutions, right? So the first one is ensure product immunity. To ensure the product immunities, there are few steps, right, we can consider. So the first one is measures should be implemented to design in appropriate immunity characteristic. And the next one is system and component testing can be conducted by simulating external sources to ensure immunity characteristic. I hope you guys understand really well what is the immunity characteristic, because I just said just now in the problems. So next we move into the EMC circuit design for immunity. Okay, there are a few parts for the EMC circuit design to be implemented in the circuit. So the first part is add series inductance to sensitive input output. Next, add parallel capacitance to shut radio frequency away. So the next buffer or isolate circuits. Buffer or isolate circuits like opto isolator or the transformer. So the fourth one is keep circuit gain bandwidth to minimum required. Okay, the last one is application of localized shielding on devices. So we need to consider all this to reduce the immunity issues in these devices, in these very needed solutions for these devices, right? So okay, last we will talk about this solution in immunity issues is bulk current injection test method for immunity. So the short form for this method is BCI test method. Okay, what is BCI test method? BCI test method is injection of radio frequency or pulse energy on wiring harness with typical BCI testing at 400 MHz. Okay, so we move to the emissions issues, the solutions of these emission issues, which are wiring to minimize EMC. The recommendation that they provided is route wiring away from the ignition system, spark plugs wires, and also alternative wiring. Don't bundle antenna, speaker, and or power wiring with vehicle wiring. This is not good. That is not good. it caused the emissions issues to be higher than the original one. So the rationale of what they provide, the solution they provide is the high energy noise may couple inductively or capacitively into wiring. So low level signals can be affected by high power circuits. So that is the rationale of what they said in the recommendation. So you need to know, you need to hear, you need to think about this more. Okay, last but not least, so we are going to an end for the solutions for these emissions issues. Okay, so the solution is protection. Protection is required to minimize effect of transients. So the circuit provisions for overvoltage, load dump, and reverse battery should be made. And next, transient protection should be on all input, output, and lines going to vehicle power. But realize that all vehicle devices may not have extensive transient separations needed by the sensitive input-output. So we need to reconsider of all devices we want to implement these solutions. Not all devices are the same. So think carefully and do it carefully. Okay, thank you.
These three companies are known to be the benchmark of RF technologies applied in automotive vehicles: Ford Motors, General Motors, and Toyota. There's more information about these three key companies in a competitor analysis. GM, this General Motors, is an American multinational corporation headquartered in Detroit. Designs, manufactures, markets, and distributes vehicle parts. One of the examples of RF technology that it has produced is a track and trace data board. GM has used radio frequency identification tags, RFID tags, for more than 10 years to identify assembled engines, but now because attaching the RFID tags directly to the cylinder heads and engine blocks using what the company calls a data board. It records every single manufacturing process the engine block or cylinder head undergoes, and that is the key to the whole track and trace system. All of the data from each bolt gets uploaded to servers housed at the factory. Next is Ford. Ford Motor Company is an American multinational automaker. Ford is the second largest US-based automaker behind General Motors and the fifth largest in the world behind Toyota, Volkswagen, Hyundai, Kia, and General Motors. This information is based on 2015 vehicle production. Ford collaborated with TNT Logistics North America, placed tags, RFID tags in vehicles for improved tracking. TNT Logistics North America is a part of a global logistics company that designs, implements, and operates complex supply chain solutions on a national, regional, or global scale for mid-size to large enterprises. This implementation of RFID tags helps its automotive customers automate workflow, provide real-time visibility, reduce inventory, and prevent business interruption in their complex supply chains. Other than implementing RFID tags in vehicles to improve supply chains, Ford Motor Company is also behind the security lock, also known as Passive Anti-Theft System. PATS is Ford Motor Company's immobilizer technology. In 1996, the technology started showing up on select models of Ford, Lincoln, and Mercury vehicles. The keys have a radio frequency transponder and embedded in the plastic head with a unique electronic identification code. Next up, Toyota is a Japanese multinational automotive manufacturer headquartered in Toyota. Aichi, Japan, is the world's market leader in sales of hybrid electric vehicles and one of the largest companies to encourage the mass market adoption of hybrid vehicles across the globe. One of the products is a wireless unit for ITS Connect service. The wireless unit for ITS Connect service is a radio communication device to help prevent road accidents and improve traffic efficiency. Ooh, that's cool, guys. It's a cooperative driving support system that uses the dedicated ITS frequency of 760 MHz for road-to-vehicle and vehicle-to-vehicle communications. Other than that, Toyota has also made a breakthrough to overcome some of Toyota Central R&D labs and researchers at the Toyohashi University of Technology. So these researchers in Japan, though, may have came up with a breakthrough to overcome some of those obstacles by powering an electric car using short-range radio waves, RFID. And this breakthrough came from Toyota Central R&D labs and researchers. It involves converting electricity into radio frequency using high-speed inverters. Next up, on this slide, is a strength analysis on these three companies. GM is focused on strong product designing and developing capabilities, including EMC tests. GM does EMC tests in every product, emphasized on GM, General Motors, also General Motors, okay, serious. General Motors, GM has focused on strong product designing and developing capabilities, including EMC tests in every product. Other than that, the thing about GM is that it really emphasizes on creating environmentally friendly and sustainability policies, which in turn enables them to produce safe and eco-friendly vehicles. That's nice. They're going to test EMC, so they don't need to rely on other people, on other EMC facilities, because they have their own EMC facility. That's great. For Ford Motors, the good thing about Ford Motors is that on the other hand, Ford Motors includes EMC requirements for both the complete vehicle and requirements for components and subsystems. They figured that out. Ford Motors also implements robust processes on the vehicle's electrical system and subsystem, which is great. And lastly, Ford Motors only accepts reports from Ford accredited EMC labs, which is great. That's great. Okay, that's great. And last but not least, Toyota. Toyota has this strong focus on innovation and R&D. Among all the automotive, it has the most investments on R&D compared to every single automotive company out there. It has helped in bringing out latest technologies in varied areas, including technologies which brings out new EMC issues and solutions. Toyota has the largest investment research and development facility, which is a big plus. They've invested the first to find probable solutions, the first to identify issues. So basically, Toyota is a pioneer. To put this in a nutshell, each and every automotive company has their own strengths and weaknesses, and they're focused on different ways to boost their product. To conclude, this unique value proposition between these three key companies, they all have something to offer, and they are all competitors in the application of radio frequency in the automotive industry. Next up is the technical analysis on these three major key companies in the RF industry, radio frequency industry. GM has an upgraded and expanded EMC, you all know from the last slide, has their own test facility, which is awesome and great. So they've upgraded and expanded EMC test facilities with four, not one, but four, not one, not two, not three, but four state-of-the-art EMC testing chambers. Other than that, GM uses the mode stirred and mode tuned techniques as alternatives to the ESLE, where mode stirred, mode tuned, and ESLE are all methods to measure the RF. They are mode stirred, mode tuned, and ESLE techniques, methods and techniques to measure radio frequency in their products. GM needs fewer changes to conduct immunity transient General Motors needs fewer changes to conduct immunity transient testing specifications. The direct capacitor coupling for input and output lines now is an option. It's great. Meanwhile, Ford Motors out here. Multiple cylinder internal combustion engine for controlling a plurality of accessories coupled to an engine crankshaft by an electromagnetic coupling device, suspension damper with integrated controls to alleviate coupling device. So that helps. And third, Toyota uses electronic apparatus with pocket of low permittivity material and has a sensor operably connected to the power integrator controller for sensing a predetermined amount of electromagnetic interference. See, all these technical things for these three companies is their technical approach to solve EMI and EMC issues and to boost their quality of product. Where GM is focused on their own EMC testing chambers, Ford is focused on coupling devices. Toyota has a sensor